Hello, today we want to talk about two-sum question which can be quickly scaled to three-sum or four-sum, essentially into k-sum. Two-sum question starts simple as we have a list of the array and the target to match. Try to pick two numbers that sum into the target. This question starting with a sorted array. Well, the reason we want to make it sorted is that these sorted array can form a unique combination that can pick in two numbers out of the array and meeting the target. Starting with the most left and right, making it two pointers, and these sum will try to match with the target. If the target is higher than the expected results, then we know the expected result needs to bump into higher, which will move the left pointer to the right one so that overall sum can be increased. If the target is actually higher than the expected outcome, we know the overall sum needs to be reduced. So that will move the right pointer one left, so that overall reduce the overall sum. In that way, we are travel through the whole array in a two-pointer way and finding unique combination of which is matched to two numbers that can be sum as a targeted number. So this is a baseline for the two sums question, and we can quickly find out this into three sum or four sum or essentially k sum. How we do that as three sum, we just pick still working on target, still working on sorted array, but we're trying to pick one number up front as fixation. For this fixture of the number, using the rest of the value as a two-sum question. So imagine there's one number in here, then we're picking this number as index, as anchor point, then the rest of them is used as a two-sum question we just explained. Similarly, we move the target, we travel through the target, and the remaining right side of the array becomes a two-sum question. Essentially loops through all that to make a three-sum question. Four-sum is even simpler, just making sure this loop wraps through another loop as a three times loop. In the two-sum, the complexity is O(n), and in the three-sum, the complexity is going to be it's going to be n squared. And in the four-sum, the complexity is going to be n powered by 3 on the time complexity. So let's quickly go through the three-sum questions. We see it is initialization, that's fine, but sorted array, we sorted first as it's always ascending orders. Then we try to pick the anchor point for I. I goes through the number from beginning to the path, then leaving to anchor point at the end, which is size minus by 2. And when we finding there's three problems we are doing here, but let's ignore this for now. And then once we find the anchor point, we'll find the left pointer, which is I plus 1, and we'll find the right pointer, which is the last items. As long as the right item is smaller than as long as the left item is smaller than the right items, we try to test the sum to matching with the target. In here is 0. And when the sum is 0, is meeting with the target, then we know we'll find a match. In this, when we're finding a match, we adding this back into our array and try to bump up the j in here. When we bump up the left ones, and when we don't want to find any duplicates, in case there is duplicate numbers, we want to make sure the bump up number checking with the previous number that's just added into the array is not equals. If it equals, we just continue bumping it up. In that way, even though we're leaving leaving the right pointer the same, but we keep bumping up the left numbers. And in that case, when we are seeing when the sum is not matching with the target, is smaller, we know we need to increase the overall sum. And when the number is larger than target, we know we need to decrease right target into moving to left. That's the expected array. In here, we can change in the k's in here as well. But I guess the k will be absorbed by this overall array as well. And there are for the promise we have done here as when we move the i's, because I is picking the each anchor point. If the anchor point is gone the second time is similar at the previous point, we know we want to skip them. We can easily skip them by checking the I numbers that had just moved, because this is the second time already, is equal to the previous time. We want to skip it. And when this is smallest point and it's still larger than the target, we know there's no point of us checking this further, so we can break this point. And when we're checking the largest point, which is I and plus the last two nodes, because we know we leave the two anchor point in here, this is still the smaller than the target. We know there's probably no point for us to checking there's no point for us to there's still hope that this I is not meeting the threshold. Then in this point, we know there's no point for us checking the I and the J anymore, because the uppercase of the I will not meeting the target of will not exceeding the target, so that we can short circuit this array itself, just keep moving the I itself, just keep moving the I to the left, so that we know the anchor point has this chance to increase the overall sum to be meeting with the target. In this case, we're not breaking it, which is simply moving the I to be larger. In this case, we need to break it, because the overall i's, even for the smallest one, is still larger than the target. Then there's no chance for the I moving larger or meeting the target. So the I is exhausted. The I has been trying all the possibility in here. This is pretty simple, and as it works, for the full sum is essentially the same. We just need to leave, instead of leaving two spaces, we need to leave three spaces in here. And similar cases, if the I has been tried once and the I wants to have met a similar occurrence, we want to continue it. And the J here is just another wrapper of the array, making J as one step ahead of I, and basically anchoring the J's to be, if it's tried once and then it meeting a similar case, we want to continue it. And as for these two, it's quite identical, looping through these two types of arrays already. Then the rest is a similar of 2K problem of us making sure it is finding the right finding the left pointer, as well as finding the right pointer as the last item. As long as the left pointer is still smaller than right items, we try to this is debugging code, but we try to find the sum and try to match the sum with the target. Sum is larger, we decrease it. Sum is smaller, we increase it. If it matches, then we add it in, and then we move two pointers in. And in this, we have done the exhaustive two-way of duplication checks, that as long as the left pointer, once we have moved, is equal to the previous pointer, then we want to keep increasing the value. For the right pointer, as long as we decrease it and we find it similar, we want to keep decreasing the value as long as we find a difference. And then once again, we'll try to check if the x and y has been met, or is there still a possibility for that to check. As this is a pretty simple as 4K problem. So let's end my demo. Hopefully, give a good comprehensive view about K sum problems.